Okay, this class we are going to discuss about satellite networks and its network architecture. That's the first topic we are going to discuss. And this chapter also will discuss VSAT, very small aperture terminal systems, will be our main topic. So when we come to VSAT, we'll discuss what a VSAT system is, what are the key components of a VSAT network, what are the benefits, advantages, and applications of VSAT, what are the limitations, what factors you have to consider when you use VSAT, and we'll see the implementation of this system. Before we come to this very small aperture terminal network, satellite network, let's see some introduction on the satellite network and its architecture. So this is what we call it, you see on the diagram, is a global network infrastructure. Looks like this. GNI indicates global network infrastructure. So satellite is integral part. It's one of the components of this global network infrastructure. To explain this, let's take example. So the sender in the source host, as you can see here, using these applications, it can be, for example, email application, wants to communicate with a destination host at a far distance here. So here is our receiver. So how this communication takes place? On the global scale, on the global network infrastructure, you will find different type of communication links to connect different hosts in the globe. So to connect this source host with the destination host, let's take some example. So the source host, which uses, let's say, an email application, it can be any application, it can be video, audio, data, or a combination of this. Now, source host connected to the first node in our this global network infrastructure. Let's say this link, we establish a microwave link. Microwave link is also part of the global network infrastructure. So microwave wireless link. Okay, now the source host and the first node linked by this microwave communication link. Then our information will be go through this switching. You can use either circuit switching, packet switching, or multiple protocol level switching. This message transmits through different nodes until it reaches the destination, right? It can follow different paths. Let's say we are using level 3 packet switching. So this node connects our packets, message packet transmits from, let's say this is our node number 1 to node number So let's say this is A, this is B. Okay, this is our network cloud. Then, as you can see, different paths. This is another path. You can see it is a link, right? Connect node A with node, let's say C. It is what? A link. This case, the network based on the routing protocol choose the link here. This link. Okay, this is not a dedicated. This is packet switch network. So let's say this link is optical link or fiber optics. We call it optical link. So fiber optical link. Okay. So node number B is connected with this satellite node. We call it Earth station. This is a satellite node. We call it Earth station number one. Earth station number one. In this case, the uplink Earth station. Here you can use another type of link. For example, again, a microwave link is used. Terrestrial microwave. So now the message reaches the Earth station. What is the next link? From Earth station 1 to Earth station 2 in another part of the globe. These two satellite nodes linked by what we call it satellite link. Satellite microwave. Now our signal reach, our message reach another Earth station, another satellite node. From this satellite node to the destination host, you may use another link. Okay. Then now the receiver gets the sent message. So in this example, you can see in the global scale, in the global network infrastructure, there are different type of links. Microwave link, fiber optic link, satellite link, satellite network is also part of this global infrastructure for communication purpose. Okay, it is a part of. That's why we'll discuss in this chapter what is a satellite network and network architecture for satellite communication. By taking VSAT, we'll take VSAT as an example, and we'll discuss this very important network, satellite networks for global communication. Now let's go in a little bit in detail to this satellite link. Let's zoom to the satellite link. Okay, so when you see a satellite link, the first thing comes to is we have networks on the ground, right? We call these networks terrestrial networks. Terrestrial networks. Here I have one terrestrial network. Here, this network, it can be a 3G, 4G, or the coming 5th generation mobile communication links. Networks. It can be PSTN, public switching telephone network. It's also another type of terrestrial network. Or you can take ISDN, integrated service digital network. Okay. So here you see the users. These are user terminals. For voice, for data, for video, or a combination of this. Now there are all these user terminals connected to a terrestrial network on the ground. As we have discussed in the global network infrastructure, satellite link is also part of it. So if one user in this terrestrial network wants to communicate to another user, this also user terminals. This is another network, another terrestrial network here. So one user in the first terrestrial network here wants to communicate with a network in the second terrestrial network, with user with second terrestrial network here. So this terrestrial network has what we call it fixed earth station, or you can call it gateway earth station, GES. It's called what? Gateway earth station. And here we have a link, satellite link. We call it uplink. Now, user from terrestrial network number 1, this user is in this network, wants to communicate with another user in the second network. Terrestrial network, you can take it as network in one country, another terrestrial network in another country. So users are connected to these terrestrial networks. So now this terrestrial network has a gateway station, gateway earth station, and the satellite also has downlink. This is downlink. So it goes to another gateway earth station, GES. It is fixed. Okay. So here you can see the earth stations, two types. In this case, we are discussing earth station called GES, gateway earth stations. This case, we classify earth station, satellite earth station, into two. The first one is called gateway earth station, GES. The second, what we call it, user earth station, UES. So in user earth station, when you see this home satellite TV we are using in our homes, so this satellite directly connected to this earth station, directly connected to the satellite without any terrestrial network, right? When you access satellite TVs, you are not go through any terrestrial network. It's independent of any terrestrial network. You can directly access, connect to the satellite. Same type of earth stations, they are called UES. user earth stations. How about GES? In this case, this user, in order to communicate with another user in another country, another terrestrial network, it's not direct access to the satellite. The access is through a terrestrial network. Each terrestrial network has one fixed earth station, so it's not direct. Users, they are not directly access the satellite. The access, before access to the satellite, they must access the terrestrial network and through this GES. What we call it, say, type of earth stations? Gateway earth stations. But in UES, users direct without any 3G, without any 4G network, without any PSTN network on the ground. If you have direct access to satellite, that earth station is called UES, okay, user earth station. So this is based on user. Earth stations are classified into two, UES and GES. This is based on user, direct access or indirect access. That's another thing. Earth stations also classified into two. Another classification of earth stations also classified into two. First one is called fixed earth stations. Fixed earth station. Okay. This classification is based on mobility. This classification is based on what? Based on mobility. Earth stations are classified into two. So some earth stations are transportable. Some stations are fixed. Transportable. Okay. Earth station. And fixed earth station. So when you see this GES, Gateway Earth Station, it's fixed in one place. It's not movable. It's installed to use as a gateway for one terrestrial network. So it's fixed for fixed satellite service applications. But earth stations also, it can be portable, transportable, like this, as you can see here, the airplane, earth stations on the ships, on the cars, GPS, handheld terminals, mobile phones. All these are, they are not fixed. Okay, this earth station is transportable. So based on mobility, earth station can be fixed or transportable. Based on user, earth stable can be gateway earth station and user earth station. Another thing I want you to see here, so far we discussed link between satellite and ground, right? There is also a link between two satellites. Satellite to satellite link. This, what we call it, ISL, inter-satellite link, is also part of the satellite networks. Okay, it's also part of, but it is optional. In some cases, you will find this link. In some cases, in many cases, in many satellite networks, they don't have this ISL. Some cases you will find ISL, especially in the low Earth orbit network, low Earth orbit satellites. You will find this link, inter-satellite link. Okay, now when you come to the network, you know the general networking. Satellite network also shares some concepts from general networking. When you discuss networking, we have topology, network topology. Networks can be configured either in star topology, mesh topology, bus topology, and so on, as you have discussed in your networking and switching courses. So satellites also configured, satellite networks also configured mainly in two topologies. First one, what we call it star topology. We'll discuss this later when we come to VSAT. When we discuss VSAT, we'll see these topologies. So as you can see here, this VSATs, VSAT A, VSAT B, and VSAT C access the satellite through a central hub, right? First configuration. We call this what? Star configuration, topology. Also, you can see without any central hub, one VSAT terminal communicate with another with a dedicated line. Such topology is called mesh. Okay, so like this. In this case, it is part B is mesh. So just like general networking, when you see satellite networks, you find topology. Okay, so satellite networks can be configured in star configuration, star topology, and or mesh topology. This is in terms of topology. You know this clearly in the general networking courses. When you come to transmission technology, again, satellite networks, just like other general network, it can be point to point, point to multi-point, multi-point to multi-point configuration. This is the transmission. For example, here you can see point to multi-point topology. It can be point to point, okay? It can be one Earth station communicate through a satellite link to another Earth station, okay? In this case, it is point to point, right? But here, point to multi-point, like direct broadcast satellite TV, TBS, it is point to multi-point broadcasting topology, right? If you need high capacity link, it will be a point to point, one dedicated link for two terminals. In some cases, multi-point with multi-point configuration. So this is our transmission, just like the general networking. You can configure the transmission into point to point, point to multi-point, and multi-point to multi-point. Now, when you come to interfacing, we'll come to that. Satellite network interface. Basically, there are three types of interfaces. Three different type of interface in satellite networks. As you know, interfacing is very important. Without interfacing, there will not be any communication, because as you know, there are thousands of manufacturers, different type of equipments. So for this equipment manufactured in different places to communicate each other in a global level, in the global network infrastructure, there must be protocols, right? So there must be interface between these different. So the first in satellite also, satellite networks also, we have different type of interfaces. So the first is UES, User Terminal Interface. When you see this user as the station, what does it mean? As the station classified into two, GES and US, based on what? Based on users. The user, is it direct access to satellite or through networks? Based on the user, we classify into GS and US. So here we have interface. That interface, we call it what? It's called user terminal interface. That's the first type of interface in satellite networks. To interface user equipments, user terminals with the satellite, there must be a protocol, interfacing protocol. Then we call it UES. But in GES, as we have discussed, based on user, some of the stations are GES, gateway as the stations. In this case, not direct user to satellite communication, but terrestrial network. As you can see here, it can be this 4G, 5G networks, PS10, public switching network, integrated service digital network. These terrestrial networks will communicate with the satellite transponder in space. Again, here we need an interface, but the interface is here different. The interface is between what? The network on the ground with the satellite transponder. That interface is what we call it GES. Gateway or the station terrestrial network interface. Okay, that's another one. So finally, as we have discussed, in low Earth orbit networks, there is a link, we call it ISL. This link is communication between one satellite and another satellite. Okay, so this satellite, to communicate with another satellite, there must be interface, right? It must be interface. That interface is called ISL interface. So basically, in satellite networks, there are three types of interfaces. One, US user terminal interface. One, gateway earth station terrestrial network interface. Third, ISL intersatellite link interface. Okay, three type of net interface used in satellite networks. So when you come to satellite networks, generally this network architecture is split into two segments. The first segment, as we have discussed before, we call it space segment. The second segment, what we call it ground segment, equipment on the ground. So when you discuss about the satellite network architecture, it's better to split into two segments: space segment, ground segment, right? So on the space segment, what do you have? Just to remember, we have discussed this before. In the space segment, we have the payload, communication equipments, the transponder part, and the antenna part we classified as payload. right? This is part of the space segment, and the support structure, the solar power system, telemetry and control, all these additional equipment systems in the space segment, we categorized this as bus, right? Okay, payload and bus. These are in the space. Now, in addition to this communication link between the transponder, antenna on the space, and antenna on the station on the ground the segment, there is a link, as you can see here. Okay, this uplink or downlink, this link, communication link. In addition to that, there is also another link here, what we call it satellite control center on the ground. Communicate with, you see here, telemetry link. This link is called separate dedicated link. So previously, when we discussed space segment, we discussed what? The transponder part, the payload, and we have seen the bus, like the solar arrays and so on. Now we include one more center. We call it Satellite Control Center, SCC. As you can see here, it's usually positioned on the ground, but it is considered as part of the space segment. Okay, what is this? What is the function of this Satellite Control Center, SCC? In our satellite network architecture, we have SCC. Using separate dedicated link, in addition to the communication link, here is a communication link. There is one more link separate with the communication link, which is used to control the satellite altitude. So, okay, the height, the speed, all these satellite parameters, you can control it from the ground. Okay, so how we are going to control your satellite to stay in that particular orbit, to rotate with fixed speed, all this adjustment from ground, you can control it by separate link. Don't mix with the communication. Communication link is separate one. This link is dedicated for control of the satellite. We call it telemetry link. So Satellite Control Center, SCC, is part of our satellite network architecture. Another part you see is NCC, Network Control Center. This center is to allocate, to manage the bandwidth of the satellite. As you know, satellite bandwidth is very limited, so there must be some control management for access mechanism. There are so many users want to access this fixed resource, fixed bandwidth, so there must be a center to manage this spectrum of the satellite bandwidth. That center, we call it Network Control Center. Previously, NCC was in the ground, but in modern satellites, you'll find this Network Control Center integrated in the space. Okay, it will be system which will be integrated in the satellite itself, in the modern satellites. But previously, there is NCC on the ground, which is used to manage access to the satellite bandwidth. There is SCC, Satellite Control Center, using a dedicated telemetry link. You can control the altitude, speed, orbit of this satellite in space. So all this, we call it a space segment. Okay, we call it what? Space segment. What are the space segment? satellite itself, which consists of bus and payload, plus 2 more control centers, one SCC, one NCC. Satellite control center, network control center, all this in general, we call it what? The space segment. That's one segment of the satellite network architecture. Another segment is the ground segment, as you can see here. We have discussed in chapter 2 this ground segment. Okay, so we are not going to discuss the ground segment, but this is what satellite network architecture looks like.